Our inference procedure is the confidence interval for slope. It tests if there is a relationship between two quantitative variables. The variable b represents the slope of our line. The equation we use is b plus or minus t star times the standard error of b.
The question our experiment addresses is, does the height of a person predict the number of baskets they can make?
The interval that we are doing requires what we call liner. L stands for linear, which we will look at the residual plot at our x and y's values to make sure that they are linear. I stands for independent. We are making sure to not sample more than 10% of our population. N stands for normal. We'll look at the MPP of our residuals plots to make sure there are no patterns. E stands for equal variance. We will look at the standard deviation and look at our residual plots of our standard deviation to make sure there is no fans. And R stands for random, which we will complete with a random sample or a random assignment. Possible lurking variables can be previous experience playing basketball, athletic ability, and gender.
To start off our panic, we will start with P, or our parameter of interest. This is the true slope of the height of a person and the number of baskets they can make.
In order for us to proceed, our assumptions must be met. We will use liner. L stands for linear. We see no obvious patterns in our residual plot. I stands for independence. I know they are greater than or equal to 350 EVHS high school upperclassmen. N stands for normality. Our MPP is approximately linear, so our data is approximately normal. E stands for equal variance. We see approximately equal variance in our residual plot. R stands for random. We did this experiment with a random sample.
To name our test, we will do a t-intervals for slope using linear regression, one-tailed for beta at alpha equals 0.05.
The I in panic stands for interval. The equation we use is b plus or minus t star times standard error of b. When we plug our equation in, it becomes 0.1193 plus or minus 2.035 times 0.0741. When we actually equate this, it becomes negative 0.0315 to 0.27012. The C part of the model is our conclusion. I am 95% confident the interval negative 0.0315 to 0.27012 captures the true slope of height of a person and the number of baskets made. If I repeated this process many times, 95% of all intervals would capture the true slope of height of a person and the number of baskets made.
So if we were to repeat this experiment again, or if others chose to do this experiment, we suggest that you block by gender and you use an actual basketball hoop instead of a toy basketball.